Hello and welcome to this how-to video on getting started with trackable entities with the repository and unit of work patterns. You can get more information on trackable entities by visiting the documentation webpage at tonysneed.github.io/trackable-entities. There you'll find a series of getting started tutorials, which you can view by clicking the Getting Started link. And from there, you can view step-by-step instructions on how to get started using trackable entities with the repository and unit of work patterns. These instructions will show you how to build an ASP.NET Web API application using trackable entities with the repository and unit of work patterns. For this tutorial, we're going to use Visual Studio 2013. Trackable Entities is compatible with both the free Community Edition of Visual Studio as well as with Professional or Higher Edition. You can create an application that uses the repository and unit of work patterns by creating a new project in Visual Studio. Then under Visual C#, select the Trackable category. And there you'll find the Trackable Web API application with repository and unit of work. At this point, you're going to need to decide what kind of entities you want generated for your project. The choice is between separate client and service entities or a single shared entities project that is referenced by both the client and the service. So if you think you need to support clients on different platforms, choose separate client service. And from there, you can select the portable option. The wizard will generate a multi-project template which includes a project for the Web API service, as well as persistence and EF-specific service projects. After creating a new project, you're going to want to update the NuGet packages for trackable entities. You can do that by right-clicking on the solution and selecting Manage NuGet Packages for Solution. And here you can see there are updates. So we'll start with the client. Then we'll update the patterns package for EF6. Once the packages are updated, be sure to build the solution. Next, we're going to want to generate the service entities. To do that, we're going to use the EF6.x tools for Visual Studio. And to use those, it's quite simple. You simply add a new item to the service entities project. Select the data category, and from there choose ADO.NET Entity Data Model. Here you can choose either EF Designer from Database or Code First from Database. Trackable Entities supports both. However, I recommend you choose Code First from Database because EDMX-based models will be deprecated in a future version of Entity Framework. Here you're going to select or create a new data connection, connecting to SQL Express, and selecting the Northwind Slim database. Here we'll accept the defaults, and we'll bring in all of the tables. Here you'll get a class that extends DB_context, which has properties of type DBSet for each of the entities that we imported. Next, we'll generate client entities, and this time we're going to use the Entity Framework Power Tools. You can select Entity Framework by right-clicking on the project, and then select Reverse Engineer Code First. Here we'll connect to SQL Express, and the EF Power Tools will generate entities for all the tables in the database. The EF Power Tools will create a DB_context class, which we can then delete. We can also delete the mapping classes, and after adding the entities, you're going to want to build the solution once again. We're going to begin by adding some repository interfaces to the persistence project by right-clicking on the repositories folder and adding a new item. From here you can select the trackable category and the patterns subcategory. We're going to choose the entity repository interface template. Here we can add the iCustomer repository interface. We'll then be prompted for an entity, which we can select from the drop-down list, and then type the plural form, which is the entity set name. This will provide us an interface for our iCustomer repository. Let's do the same for an iOrder repository. Here we'll select order and type in orders as the entity set name. And now we have our iOrder repository interface. First of all, we're going to need to change the data type of the parameter from int to string for the iCustomer repository because the primary key in the customer table is a string data type. Next, we're going to want to add a method to our iOrder repository, an overload of get orders which accepts a customer ID. Next, we're going to add an iUnitOfWork interface, and we're going to call this iNorthwind Unit of Work. And here we've got some to-do items. We've got two repositories, iCustomer repository and iOrder repository. Next, we're going to want to open up the service.ef project and select the contexts folder. Here we're going to add a context interface, which is going to introduce a little bit of loose coupling for our DB context class. And from here we're going to select Database Context Interface. Here you're going to see some to-do items. So here we'll bring in the namespace for our entities, and we've added an IDBSet property for all of the entities exposed by our DB context class. We're also going to want to alter the context class in order to implement this interface. So what we'll do is we'll start out by copying the Northwind Slim class from the Service Entities project into the service.ef project. Here we'll go ahead and rename it. And as you can see, we need to change the data type of each property to IDBSet. Next, we're going to want to add concrete repository classes to our service.ef project. From here, we can add a customer repository. We'll select the customer entity, and as you can see here, we have some to-do items. The first one is going to be to bring in the context interface. So I'll just search and replace those. Next, we're going to also need to change int to string here in the concrete repository in order to match the interface. Now we'll add an order repository. The interface has a method called getOrders, which accepts a parameter of type string, which is customer ID. We'll need to include that in our order repository as well. It also has a to-do item here for including related entities. We can simply then copy and paste those two include statements. And there's just one include that we'll need to add for the delete order. And lastly, concerning our patterns, we're going to need to add a concrete unit of work class to the service.ef project. And here we can name it Northwind Unit of Work. The first thing we're going to do is add read-only fields for each repository interface. We're then going to need to refactor the constructor in order to accept both the database context interface as well as our repository interfaces. Lastly, we're going to need to add read-only properties for each entity repository interface. So what you see here is that the unit of work exposes the repositories as properties, and then in addition has methods which span those repositories. And the very reason we need to use a unit of work pattern for this is because all of the changes to various repositories we want to encapsulate within a single unit of work because it belongs to the same transaction. Then we're going to copy the database connection string from the service entities app config file into the web.config file of our web API project. And the last thing we're going to want to do here is to add controllers to our web API project which use the unit of work and repository interfaces. This will allow us to add a customer controller. And now we have a controller where we can complete some to-do items. The first order of business is to replace iExample unit of work with our iNorthwind unit of work. And next, because this is the customer controller, we're going to want to replace int with string. And you're going to see here that we are accepting as a parameter the unit of work interface. It has the repositories as properties, and each of those repositories has methods which allow us to interact with that repository in a decoupled manner. The idea, of course, being that the Web API service is now decoupled from Entity Framework as the persistence API. Next, let's add a order controller. We'll select the order entity, and we'll perform the same replacement here of the unit of work interface name. And as you recall, the orders repository has an overloaded getOrders method, which accepts a parameter of type string, which is the customer ID. So we'll add a controller that performs the same action. And you'll also notice that we're implementing iDisposable on our unit of work. In order to remain decoupled from infrastructure concerns, our Web API project is using dependency injection in order to create instances of our concrete unit of work and repository classes. As you can see here, the DI framework that we're using is Simple Injector, and this is where we're going to initialize our DI container. And of course, if we had any other repositories, they would all need to be registered here as well. Now, to test our Web API service, we're going to simply build our solution. Then we're going to view in browser. We can test these. I'll just click send, and this will retrieve all the customers from the Northwind Slim database. I'm going to want to go ahead and copy down the port number that is used for our Web API service. And the reason I'm going to need that port number is to paste it into the code in my console client. And for now, I'm going to comment out the code which is used to update orders. And I'm going to uncomment some service helper methods, which are using HTTP client to communicate with the Web API service. To test the client, I can simply set it as the startup project for the solution. Here you can see I've retrieved all the customers from Northwind Slim. Lastly, I'm going to uncomment the code in my client, which is used to create and update orders. You can see that we're starting out by creating a new order, then calling the createOrder method, which inserts the new order into the database. Then we're going to pass the order to a new change tracking collection of order. We can call this getChanges method on the change tracker in order to get only the entities that have changed. After that, we can pass the changed order to the API service. Once we receive back the updated order, we can call merge changes in order to update the original order with the database generated values. Lastly, we'll delete the order and verify that it's been deleted. Now we simply run the console client to verify that the orders are properly updated. And thank you for using Trackable Entities with N-tier support for Entity Framework in order to create Web API services which use the repository and unit of work patterns.